Let's continue with basic differentiation. In this video, we will learn how to apply basic rules of differentiation. This is the next basic rule of differentiation. If you're given y equals to function fx and it's raised to a power n, where n is a constant, then when I differentiate, dy dx will be equal to n times fx. Fx is now raised to power n minus 1 times an additional portion, which is the derivative of fx. So there is an extra bit here that we have to take note of. I'm going to show you the proof of this formula. So I have y equals to fx and fx is raised to power n. So what I'm going to do is I'm going to let u be fx. And since I let u be fx, my y can then be written as u power n. And if y is u to the power of n, and if I differentiate y with respect to u, applying the first formula we learned just now, it will be bring down power will less 1, and this is the dy du. Now, over here, since we let u be fx, if I were to differentiate u with respect to x, I get f prime x. Because I differentiate fx, I get f prime x. Now, what I'm interested in finding is not dy du, it is not du dx. What am I interested to find? I'm interested to find dy dx. So, what is dy dx? According to chain rule, dy dx can be found by taking dy du times du dx. And since I've got dy du somewhere, I've got it here. Let's put it in. I've got du dx somewhere. Where is it? Over here. I'll put it in. Now remember, I let u be fx over here. Let's put that back here into u. So here you go. This is the formula that's reflected here. This is the proof. I'm going to illustrate this formula with a few examples so you know how to use the formula. And the first example will be this. I'm given y equal to a function in x. This is the function in x, 2 minus 5x. And it has a power of 3 over 5. The question is, what is dy dx? Applying this formula, dy dx is equal to, bring down the power 3 over 5. Fx still remains. And the power of fx now changes to negative 2 over 5. Why is this negative 2 over 5? You're right, it's because I take the original power 3 over 5 and I minus 1 from it, so I get minus 2 over 5. And don't forget this extra bit here. So, I'll need to go back to the function fx and differentiate. So if I differentiate the first term 2 being a constant becomes 0. If I differentiate minus 5x, it will give me minus 5. Now let me simplify. I take 3 over 5 times minus 5 here. I get minus 3. So this is my answer for dy dx. Let's try another one. But before I differentiate this, I need to rewrite this by bringing this x term up. So the power here is now minus 2 because I brought it up from the denominator. Okay, I think I'm ready to use this formula again. dy dx is equal to, now let's keep the 5, this is coefficient. I bring down the power minus 2. I copy the function x squared minus 1, no change to that. The power becomes minus 3 because I have to minus 1 from the original power. And don't forget this extra bit, the f prime x. So I go and look at my original fx here, and I'm going to differentiate one by one. So the first term is x squared. Differentiates to 2x. Minus 1 differentiates to 0 because it's a constant. Let me tidy things up. 5 times minus 2 is minus 10. Minus 10 times 2x here, minus 20x. One more example, you have to find the gradient of the tangent to the curve, and this is the curve equation, at a particular point 3, 2. Now recall I said earlier in the earlier video that to find gradient, it is the same as saying find dy dx. Differentiate. So I need to differentiate, and I need to use this formula. So this is the equation of the curve. Okay? Now I need to first rewrite this a little bit. I need to bring this x term up. So that I can use the formula later. Now I'm ready to differentiate. So differentiate using this formula would mean, let me keep the coefficient 2. Then I bring down the power minus 2. Then I copy the entire function, no change. And the power minus 1, so become minus 3. Don't forget this last bit here, f prime x. So I need to go into the function here, and I need to differentiate term by term. So x squared gives me 2x when I differentiate. Minus 2x differentiates to just minus 2. Now notice that every time you have minus 2x and you want to differentiate minus 2x, since x is power 1, upon differentiation, all you need is to eliminate the x term and be left with the coefficient. This will be a quick and dirty way to differentiate expressions like that. Minus 4 being a constant becomes 0. Multiply, you have this. Now they give me a point 3,2. They want to find the gradient at the point 3,2. So what I'm going to do is I'm going to make use of this point 3,2. I'm going to substitute in some values. So I'm going to substitute in x equals to 3. Do I need the y value? No, we don't need it now. So let's sub in 3. You press the calculator to get an answer, and the value is 16. So the gradient at the point 3,2 is 16.